Hello, my name is David Mason and I was the senior marker for a group of questions that were being marked by Team 7. Our first question was question 29, and this question involved the investments section of the syllabus and specifically share portfolios. It involved the students being able to do the following calculations. Find the total of ABC dividend, use that to find the total of XYZ dividend, and then use that to determine the number of shares. The question is shown there, and a sample answer is also given. Now, the question did have some issues that students come up with. However, the positive things were that the majority of students did actually engage with this question. So they had a go at it. They didn't necessarily have all the right working, but they had working that went along the right direction. A very common part to this was that students used a guess check method. So at least if they didn't know how to set up equations to do certain parts of this, they could use a guess check method to get to the right answer. And I'll talk a little bit more about why they did that shortly. The better responses showed a very structured approach. And by that, they set out their working very deliberately, and that tended to get students better results. One of the things that was probably not just for our marking team, but for a whole lot of teams, would be that the more successful attempts had the critical information in the questions were highlighted. So the students went through either using a highlighter or a pen and underlining. They identified those critical parts to the question, which helped them to actually be successful in answering the question. Common errors that we found were that they used the $149.52, which was the total dividend for XYZ company, and worked through there. So they had the right approach, they just left out a step to start with. They were using the wrong dividend yield and or the market price. So they didn't have a good look at the table that was shown. They picked the wrong price for one of those and were doing the working. Common thing was to use $5.50 twice, one for each of the two shares, or use 4% or 6% in both calculations for XYZ and ABC. Another thing that was very common, and I think this is something that we as teachers need to work on with our students, is that they rounded their XYZ dividend to the nearest dollar. It didn't seem like it was nice for them to have to use $83.52. They wanted to use $84 because they didn't want to have to deal with decimals, I guess. That was a problem. The other thing that was happening was that because of their calculations, some people ended up with a decimal number for the number of shares. And when they came up with a decimal number for their shares, they just rounded off to a whole number. And this comes back to them not actually going back to the question and looking, what is this answer giving us? Which should have been a trigger for them to see that maybe they'd made a mistake. Another thing that was common was that because it said the 30th of June in the question, they assumed that the dividends were only a half-year dividend. So took that into account to try and work through the price that the shares were, or and calculate the number of shares. And the other thing was a near enough is good enough approach. that came up from the guess check method. So they got an answer which was pretty close to the right amount of dividends when they put in a number for the number of shares, and they said that will do. They didn't check either side of. It kept going until they checked either side to eliminate everything that they should eliminate. So what do we get from that? Well, I would suggest that some learning outcomes that we can have are that students need to check whether their answer is realistic. Right? A decimal answer for the number of shares is not a realistic answer. So they should be going back and looking at that. When they use the guess check method, they also need to eliminate or refine until they eliminate all other options. It's not just guess check, it's guess check, refine. We, as teachers, should ensure that we're giving enough questions that require students to work backwards. If you go and have a look at the solutions again, the second part of it, if you set up the right statement equation, the students are doing a division. So they're working backwards a little bit and they're not confident in doing that. It also means that they probably need some work on using decimals in solving equations as well. And a big thing, which is probably going to be said by most people, is reinforce the need of students to show working, to explain the method that they're using. Because sometimes it's the method that can get the marks as opposed to the final answer. So if we're reinforcing that idea, that can be something that will help them to get to have more success or greater marks in these exams. The next question that we marked was the very next question. Question 30 was about networks. In 38 was about maximum flow. It involved one of probably three methods that students could use, recognizing that maximum flow equals minimum cut, or the fact that you could reduce and check the in and out flows of the different vertices to find out what the maximum flow was in total, and working through finding the saturated edges and adding those up was another method. There's the question. Something that I'll say now is that a lot of students didn't really read or didn't really understand what the numbers represented on this diagram. I guess the easiest thing here was the answer that they've shown is minimum cut, determine what that was, and that's your maximum flow. Positives, most students had an attempt at the question. Many of the students actually drew a cut or cuts on the diagram and attempted to calculate their values. So that was a good starting point for answering this question. It was obvious that quite a few students went on to part B and then backtracked, went back to part A to fix up their answer. So, or even initially attempted because of something that came out of part B, which is good because that means at least they're linking the two things together. Those that used the saturation method were more successful when they highlighted the paths so they could see all the different paths that they were talking through and that they didn't leave something out. Errors, they added all the edges along the path. So they thought this is a good path and then they just added up all the numbers or so many of the numbers within it. They chose 350 as the maximum flow, presumably because that was the amount that went in at the beginning and that was the amount that could go out at the end, so that must be the maximum flow. They ignored the 100, thinking it was flowing from the sink back to the source, and that being path C to E. So they were thinking that, oh, it's going backwards, so we don't count that. Or using the cut that's in part B, and this is where they could have actually started from B and gone backwards, and took off the 50 from path C to B when it is not, because it's not being used. Instead of just ignoring it, they subtracted that value. And the other was using the box terminology for the earliest start time or latest start time, those ideas. So they really didn't have an understanding of what the question was asking. Part B involved, again, using maximum flow and minimum cut recognition. Same diagram with an extra line drawn in. And the easy way to answer this question was work out what the value of the cut was in this particular part and then say, well, that's not the same as the answer to part A. It's bigger than the answer to part A, therefore it's not the minimum cut. Positives, again, students attempted to calculate the cut value. So that was a positive thing there. I will say attempted because, again, there's some similar sorts of issues. Again, in this case, instead of subtracting, often what they would do is add the 50 in the path that's going back from the source, from the sink to the source. And they got a total of 375. They were getting an incorrect cut value for part A, an incorrect cut value for this part, but it was less than the answer in part that they got for part A, so they said it was a minimum cut. Some learning outcomes for this question, I think and this is for both parts, I think the real thing here is that students need to understand that multi-part questions are linked. And I don't think that everybody worked that out. Usually a latter part relies on an earlier part. Students need to know the difference between the various network terminologies. And that was obvious that that didn't occur. And by using some of the early start time, latest finish time ideas, that showed that they didn't know that. The students need to know that only flows going from source to sink are used when determining cut values. It's not that we subtract them, we just don't use them. And the main thing for this question was that they did actually need to know minimum cut equals maximum flow. And it would have, if they knew that and could apply that, they would have been able to get 3 marks out of 3 without any trouble at all. Our last question was question 37, and it was looking at the annuities topic, and in this case using a present value table. It involved calculating the present value of a $1,000 annuity for 20 years. The annuity then changed to be $3,000 for the next 10 years, but this involves them calculating the present value for 30 years and taking away the present value for 20 years so that we could get what that extra part was. The question was fairly wordy. It was the last question in the paper. It also came after the crickets question, which being a whole page of reading right near the end of a 2.5-hour exam. And really having to get their head back into something that they understand, I think that had a very big bearing on a lot of these students. Sample answer is shown there. Many students were able to identify the correct interest values from the table. We saw that students were highlighting the 2% column. So at least they could show this is where we need to be. That shows that they can convert from percentage to a decimal. That was good. Many students were able to determine the present value of the $1,000 annuity, and that was good as well. So they'd made some progress towards the final answer. The biggest hurdles that I noticed during this were that they actually tried to use the compound interest formula. They were taking the value from the table and putting that in as the interest rate, as instead of knowing how to use that table's value, present value table's value. Okay, so that was what's on the screen now is what you would see as an example of some of the things that we saw. Another thing that was common was using the number of years in the calculation. What they didn't realise is that the number of years involved changes the interest factor number that they're getting from the table. They don't need to do times 20 in this case. They treated the $3,000 annuity as a 10-year annuity, which is understandable why they would think to do that. So they just used the 10-year interest factor of 8.983. Again, understand why they would do that, but it means they didn't have the depth of understanding about how the last 10 years there actually has the first 20 years have a bearing on that part as well. Now, this was designated as a question that was expected to be a Band 6 question. So again, we'd expect some students to have some difficulties here. What are the learning outcomes for this? Well, I think the students need to check whether their answer is realistic. Many of these students had answers which are greater than $50,000, which was, if you just took what they were getting back each year, that was $50,000. There's not too many people, I don't think, that would be wanting to put in more money to start with and only get $50,000 back in the end of it. So they need to look at that realistic nature of their answer. They need to know how to use the present value factors table, because that is what this question was really about. How do you use this table? Yes, it was difficult, but at least being able to use it to find the first 20 years, they should have, basically everybody should have been able to do. As teachers, I think we need to give students practice in answering these sorts of annuity questions where there's a change in values part the way through the annuity, so that they can get some more practice at doing these things where it's going to be difficult for them. So they're used to that to start with. And that's my report on the 3 questions that we had. Thank you.